तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Last class we were discussing about the activated sludge process in detail. Now we have seen what are the important design parameters. Okay. In that one we have seen how to calculate total sludge production, what is the loading rate we can adopt, and we have seen what is the oxygen requirement, what is the nutrient requirement, and we also discussed how to design the secondary sedimentation tank of an activated sludge process. And we were discussing about the aerators, because we have to supply excess oxygen externally by means of mechanical means, because the oxygen consumption rate in an activated sludge process is much more compared to the rate at which the oxygen is entering in the system naturally. So, if you want to meet the oxygen requirement exerted by the microorganism in the aeration tank, we have to supply that much of oxygen. So, that is why we have to provide aerators. The aeration facilities are having two major objectives. One is to provide enough oxygen whatever is required for the activated sludge process for the proper performance of the system. Second one is to provide proper mixing in the system, because if proper mixing is not taking place in the system, what will happen? All the microorganism whatever is present in the system, it will be settling down and the substrate or the wastewater will be in the top. So, there will not be any contact between the microbial cells as well as the microbial cells and the organic matter present in the wastewater. Unless the organic matter goes and get attached to the microbial cells, there will not be any metabolism taking place. So, if there is no metabolic activity taking place, definitely there will not be any treatment or any change in the status of the organic matter. What I mean is, it will not be getting converted from the dissolved form to the colloidal form or new cells. So, proper mixing is also very much essential in an activated sludge process. And this, when we talk about the mixing, okay, it all depends upon the reactor regime we are adopting. Okay, if it is a completely stirred tank reactor, we have to have proper mixing. Okay, if it is a plug flow reactor, there will not be any longitudinal mixing, but transverse mixing will be taking place, because each portion of a plug flow reactor will be acting as a completely mixed batch reactor. So, if we talk about the aeration requirement in aeration tank, it varies depending upon the process. The dissolved oxygen concentration in the aeration tank of a conventional ASP varies from 0.5 to 1 milligram per liter, whereas in extended aeration it varies from 1 to 2 milligram per liter. So, your aerators should be able to provide this much of dissolved oxygen in the system irrespective of the oxygen demand exerted by the system. So, we will be knowing what is the total oxygen requirement, that we have seen how to calculate the total oxygen requirement of a particular biological system. So, now we have to find out how many aerators we have to provide and what type of aerators we have to provide. And we also discussed that the aerators can be classified into two categories: diffused aerators and mechanical aerators. Diffused aerators are mainly used in plug flow type of reactors, and mechanical aerators are commonly used in CSTR type reactors, but they are interchangeably used in some exceptional cases. So, if you want to find out what is the number of aerators we have to provide in the aeration tank to give the sufficient amount of oxygen, we should know what is the capacity or what is the amount of oxygen that can be transferred by a single aerator. And we also discussed about what are the factors that affect the oxygen transfer. Okay, we have seen that the factors that affect the oxygen transfer are the oxygen saturation concentration or the oxygen concentration gradient available in the system. Then next one is the temperature, and third one is the wastewater characteristics, and fourth one is the degree of turbulence. If the concentration gradient available is high, definitely there will be a high driving force, okay, from the high concentration range to low concentration range. At a faster rate the oxygen will be getting transferred. So the saturation concentration or the dissolved oxygen concentration of the wastewater is very, very important, okay. That will decide the rate of oxygen transfer. And another one is the temperature, because we know that at low temperature the dissolved oxygen concentration is very high, and as the temperature increases the dissolved oxygen concentration will be coming down. The next one is the wastewater characteristics, because if the water is having too much of dissolved solids, then naturally the dissolution of oxygen will be getting affected because of that. And other parameter is the presence of hydrophobic substances. Hydrophobic substances are those which is disliking water. That means they will be having a tendency always to come out of the water. So what will happen, okay, whenever this hydrophilic and hydrophobic compounds are there, so hydrophilic compounds will always try to be in the water, and hydrophobic particles or hydrophobic compounds, they will be forming a thin layer over the surface of the water, because at any chance given to them they wanted to come out of the water, that is hydrophobic, because they just dislike the water. So these hydrophobic substances, when they form a concentrated layer of molecules on the surface of the water, then naturally if some other molecule is coming from outside and if it tries to enter in the water, definitely it will be hindered by this layer. So the wastewater characteristics is also very, very important when we discuss about the oxygen transfer capacity. And another one is the turbulence. If the water is quiescent, naturally the oxygen transfer will be less, but if the water is highly turbulent, okay, because of the turbulence more mixing will be taking place, so naturally the oxygen transfer will be higher. So when we talk about the aerators, which condition we have to talk, okay, because on different treatment plants we take, the conditions prevailing there will be entirely different. The wastewater characteristics can be changed, the turbulence whatever is there in the system can be different, the temperature can be different, and the dissolved oxygen concentration difference, okay, whatever is the saturation concentration and whatever is already present in the system, that can vary from system to system. So how can we compare the performance of aerators? So that is why we use the term rating of aerators. Rating of aerators is based on the amount of oxygen they can transfer to tap water under standard conditions of 20 degrees centigrade, 76 millimeters of mercury and 0 milligrams per liter of dissolved oxygen. These conditions are very, very important, because we are going to compare the efficiency of each aerator. So at that time what we have to do, okay, we have to maintain the standard condition. That standard condition is 20 degrees centigrade, 76 millimeters of mercury and 0 milligrams per liter of dissolved oxygen. So if you want to find out the rating of aerator under standard condition, how can we conduct the experiment? Okay, it is very easy. Okay, you have your designed aerator and you have a proper tank, okay, which is having proper dimensions. Usually the dimension of the tank is maintained in such a way that b/2, that means width by depth ratio will not be greater than 2. Okay, from the experience it has shown that if the ratio is less than 2, then the oxygen transfer efficiency is higher compared to a higher ratio. So usually they make the standard tank, then what they do is fill the tank with tap water, and definitely the tap water will be having some dissolved oxygen present in that one. So we have to make the dissolved oxygen concentration to 0. That is the standard condition. So how can we make the dissolved oxygen concentration to 0? So we have to add some reducing agents. Reducing agents are the one which accept oxygen and get oxidized, and oxygen will be getting reduced to water. So usually we add sodium sulphide, Na2SO3. So what will happen? This sodium sulphate will be combining with oxygen present in the tank, and it will be forming sodium sulphide, Na2SO4, and all the oxygen whatever is present in the system will be coming down to 0. Then you start your aerator keeping 760 mm of mercury pressure and the temperature as 20 degree centigrade, okay, and measure what is the dissolved oxygen concentration at a given time. Okay, from that one we can find out what is the rating of aerators. But this rating, if you think that the same efficiency will be prevailing in field condition, it is wrong, because field condition the situation is entirely different. The temperature may not be 20 degree centigrade and pressure may be same or may not be same, but dissolved oxygen concentration it will be different. Most of the time it will be in the range of 1 or 2 milligrams per liter. So we have to convert this rating of aerator to field condition. So for that one we use another term that is known as oxygen transfer capacity. Okay, this oxygen transfer capacity we define under field conditions, whatever is existing in the field, okay, depending upon the wastewater characteristics, depending upon the turbulence, depending upon the temperature and the dissolved oxygen concentration, we can find out what is the oxygen transfer capacity. Okay, this is the commonly used formula to calculate the oxygen transfer capacity. N is equal to Ns into Cs minus Cl into 1.02024 raised to T minus 20 into alpha divided by 9.17. Okay, here this N is oxygen transferred under field conditions, kilogram oxygen per hour. Okay, this is the field condition, and Ns is nothing but the oxygen transfer capacity under standard conditions. Okay, this Ns value will be available along with the aerator, because this will be found out by the manufacturer under standard conditions and this will be given to you. So this value you will be knowing, and Cs is the dissolved oxygen saturation value for sewage at operating temperature. Okay, so this one we can get from standard tables. What is the saturation concentration? It's a function of temperature and pressure. So if you know the temperature at that time, we can find out what is the maximum dissolved oxygen concentration, we can get it. And Cl is the operating dissolved oxygen level in the aeration tank, and usually it will be 1 to 2 milligram per liter, and T is the temperature in degree centigrade, because this is the operating temperature, because we know that the oxygen transfer capacity reduces with increase in temperature. So we have to make the correction for the temperature also, and alpha is the correction factor for oxygen transfer for sewage, because under standard condition we are finding out the transfer for tap water. There not many solids are present, or the dissolved solids concentration is very less and organic matter concentration is almost negligible. But when we talk about the wastewater, okay, the condition or the situation is entirely different. So we have to make a correction. So that correction factor is this alpha. So that varies from 0.8 to 0.85. So if you apply these corrections, then we will be getting, okay, based upon the rating of the aerator, we can find out what is the aerator field capacity, that what is the amount of oxygen that can transfer under field condition. And we have already found out what is the oxygen required by the system. So we know what is the field capacity of the aerator, and we know what is the total amount of oxygen required by the system. We can find out what is the number of aerators we have to provide, or what is the horsepower we have to provide. And here I have given the oxygen transfer capacities of various type of aerators. If you go for surface aerators, in most of the cases in India we use surface aerators. Their oxygen transfer capacity varies from 1.2 to 2.4 kilogram of oxygen per kilowatt hour. And if you go for fine diffusers, the oxygen transfer capacity is 1.2 to 2 kilogram oxygen per kilowatt hour. And if you go for coarse diffuser, the oxygen transfer capacity is 0.6 to 1.2 kilogram oxygen per kilowatt hour. The fine diffuser, it is having high oxygen transfer capacity. The reason is the bubbles whatever coming out of the diffuser, it will be very fine. So the contact area of the bubbles with the liquid is very high. So when the contact area is more, the transfer of oxygen will be very high. But the disadvantage of this fine diffuser is, okay, the clogging chances are very high, because the pores are so fine, it can get clogged very fast. And next one is or the other problem with the fine diffusers are the pressure drop experience in these diffusers are very high. So, we have to apply a very high pressure of inlet air, then only it can give the sufficient aeration. When we talk about the cost aerators, okay, the pressure drop will be very less and the bubbles whatever is coming out will be bigger ones. So, naturally the oxygen transfer capacity will be less. So, in order to increase the oxygen transfer capacity using the cost diffusers, what usually practice is use a turbine just above the cost diffuser. So, the bigger bubbles will be coming out of the cost diffuser and this turbine will be breaking the bubbles into finer ones and it increases the oxygen transfer capacity. Moreover, the turbines will be increasing or inducing more turbulence that will be increasing the oxygen transfer rate. And surface aerators, okay, the most commonly used one, here oxygen transfer capacity is relatively higher compared to fine diffusers and coarse diffusers. Okay. This is a picture of a surface aerator. We can see that the surface aerator is here and so much of turbulence is there, so much of mixing is there and it is transferring the air to the water. And this is an example of diffused aerators. Okay. This is the oxygen supplying pipes and diffusers are placed at the bottom. You can see this here. Okay. And fine bubbles will be coming out of the diffusers and it will be aerating the entire system. Okay. And once again the diffused aerators are mainly used for plug flow type of reactors and mechanical type or surface aerators are used for CSTR type reactors. And now I will give some information, okay, which is essential for the design of activated sludge process. We have discussed in detail about activated sludge process, what is an activated sludge process, how to design an activated sludge process under various conditions. You will be getting different parameters and all. So, how can we go around with the design, and we have seen that what are the important design parameters, and we also discussed about what is the purpose of an aerator and how to design an aerator or how to find out how many number of aerators we have to provide in the system. Okay, this gives the summary of the entire discussion. Okay, so here the process, flow regime and what is the concentration required, everything is given. So, I will just read out. If you are going for conventional type activated sludge process, okay, if the flow regime is plug flow, okay, the MLS concentration varies from 1500 to 3000 milligram per liter and the ratio of ml/VSS by ml/SS, that is 0.8 and F is to M ratio, that means nothing but food is to microorganism ratio or the specific substrate utilization rate. It varies from 0.3 to 0.4 and hydraulic retention time in the aeration tank varies from 4 to 6 hours and biological sludge retention time theta c varies from 5 to 8 days. See the difference, here HRT is varying from 4 to 6 hours and theta c is varying from 5 to 8 days and the recirculation ratio is 0.25 to 0.5 and efficiency is varies from 85 to 92% and kilogram of oxygen per kilogram BOD removed. Okay, usually we have to provide 0.8 to 1 kilogram of oxygen. So, from this one we can find out what is the horsepower required. And if you go for a conventional activated sludge process with a CSTR flow regime, that means completely mixed flow regime, the MLS concentration we usually keep in the range of 3000 to 4000 milligram per liter and here also MLSS to MLVSS to MLSS ratio is 0.8 and food is to microorganism ratio we can change from 0.3 to 0.5 depending upon the type of system we are adopting and HRT varies from 4 to 5 and theta c varies from 5 to 8 days and QR can vary from 0.25 to 0.8 again depending upon the process and efficiency is 85 to 92 and oxygen transfer rate is exactly the same 0.8 to 1. Now, we will come to the extended aeration system. Okay, the advantage of this system we have already discussed. There no sludge handling problem is there because entire sludge is getting stabilized or the sludges or the microorganisms are undergoing auto-oxidation. So, whatever sludge coming out of the extended aeration system is mainly inorganic substances. So, we can directly take that sludge and dispose it into sludge drying beds. So, naturally, if you want to completely oxidize the entire organic matter, then the oxygen requirement will be more. So, we will see what are the requirements. If extended aeration system, if you go for completely mixed flow regime, okay, the MLSS concentration varies from 3000 to 5000 and MLVSS by MLSS ratio is 0.6. The reason is most of the microorganisms are in the endogenous respiration stage. So, mainly you will be having inorganic, so much of inorganic substances will be there in the system. That is why this MLVSS by MLSS ratio is coming down. Now, we will discuss about the food is to microorganism ratio. In extended aeration system, the food is to microorganism ratio usually we keep very low. Okay, the value varies in between 0.1 to 0.18. Mostly the microorganisms are kept under starvation. And now we talk about the hydraulic retention time. It varies from 12 to 24 hours because entire microorganisms have to get oxidized. That is why such a long hydraulic retention time. And theta C here is 10 to 25 days. If it see the theoretical theta C value in an extended aeration system, it will come almost infinity. And the recirculation ratio is 0.5 to 1. Most of the cases what we do, entire sludge whatever is generated in the extended aeration system will be recirculated. But practically to avoid the accumulation of inorganic solids in the system, around 5% of the sludge will be wasted. That is why the recirculation ratio is coming so high. That means 0.5 to 1, that means 100% recirculation. And if we talk about the efficiency of extended aeration system, the efficiency varies from 95 to 98% because we are giving so much of aeration. So, entire organic matter will be getting oxidized. So, this is the summary of activated sludge process. And while talking about the oxygen requirement, definitely extended aeration system will be needing more oxygen, okay, around 1 to 1.2 kilogram of oxygen per kilogram of BOD removed is required because everything is getting auto-oxidized. There is no need of any sludge treatment, any further sludge treatment. Till now we were discussing about how the organic matter is getting removed from the system. But we all know that apart from the organic matter, there are nitrogenous material present in the wastewater. Okay, the nitrogen can be in the form of organic nitrogen or ammonia nitrogen. Where this nitrogen is coming to the wastewater? Because we know that the basic component of any protein is amino acids, and we will be taking lot of proteins as a part of our food, and decaying of any vegetables or any protein containing substances will be releasing this organic nitrogen and ammonia nitrogen. So, when we provide aeration, what will happen? First, the microorganism will be utilizing all the carbonaceous material present in the system. Then it will start utilizing or start oxidizing the ammonia to the most oxidized form, that is nitrate. So, for this also we have to provide some oxygen. Okay, when we were discussing about the total oxygen requirement of the system, we have seen what is the nitrogenous oxygen demand. If you have 1 unit of ammonia nitrogen present in the system, we need around 4.57 units of oxygen. That means 1 unit of ammonia requires 4.57 units of oxygen. So, who is doing the oxidation of ammonia to nitrate? Is it the heterotrophic microorganism whatever is present in the system, or is it some other microorganism? What all are the conditions which are required for the proper oxidation of this ammonia to nitrate? If the complete oxidation of ammonia to nitrate is not taking place in the treatment plant, what will happen? The effluent whatever coming from the treatment plant, if you discharge it to the water bodies, it will be exerting some oxygen demand. Okay, that is not advisable. So, complete oxidation of this nitrogenous material is also essential in the treatment plant. When we were discussing about the population of or the nature of microorganism in the activated sludge process, we have seen that there are various type of bacteria, then fungus, protozoa, etc. present in the activated sludge process. And in the bacteria, we have seen there are heterotrophic bacteria and autotrophic bacteria. So, this ammonia oxidation or organic nitrogen oxidation to ammonia, then nitrite to nitrate, it is taking place with the help of autotrophic microorganism. They are known as nitrifiers. Okay. So, nitrifiers are responsible for the oxidation of ammonia nitrogen to nitrate. This is very clear, okay, when we were discussing about the biochemical oxygen demand. Okay, if you see that biochemical oxygen demand curve, okay, with respect to time, okay, we have seen that up to 5th day or 7th day it is coming. Initially it is following the first order, then it attains the zero order reaction and it becomes asymptotic, and after certain time again there is a rise and again it will become zero order. So, the second rise is because of this nitrifying bacteria. So, initial stage whatever is the carbonaceous oxygen demand present, okay, it will be removed, then the nitrogenous oxygen demand will be exerted, because this nitrogenous oxygen demand or this nitrifiers which is exerting that nitrogenous oxygen demand, okay, it can work under, okay, these are autotrophic microorganisms. So, if the organic matter concentration in the system is very high, naturally the heterotrophic microorganism will be thriving or their population will be very high. As the organic matter concentration comes down, the heterotrophic microorganism concentration also will be coming down. At that time these nitrifiers will start their work. Okay. So, how they are doing the work? So, these nitrifiers include two sets of microorganisms. One is nitrosomonas and another one is nitrobacter. So, nitrosomonas converts ammonia in presence of oxygen to nitrite plus 4H plus 2H2O. And nitrobacter, what will they do? Okay, they are taking this nitrite and in presence of oxygen they are converting it into nitrate. So, we can see that ammonia oxidation, okay, it will be releasing hydrogen ions. So, definitely the pH of the system will be coming down. So, we have to provide enough alkalinity to the system, and moreover we have seen that these nitrifiers are autotrophic microorganism. So, autotrophic microorganism, from where they are getting the carbon for the cell synthesis? It has to come from inorganic sources. So, usually the nitrifiers take the carbon from the bicarbonate present in the system or the alkalinity present in the system. So, if you want to have a proper nitrification in your system, okay, the system should have proper alkalinity. If sufficient alkalinity is not present, okay, we have to supply alkalinity externally. And okay, now we will discuss, okay, what are the important things that is essential for a proper nitrification. One is alkalinity, okay. Second one is oxygen. We can see that for ammonia to nitrite, okay, we need 3 molecules of oxygen, and nitrite to nitrate we need 1 molecule of oxygen. So, enough oxygen supply is essential, but whether the oxygen can be a limiting factor for nitrification in the conventional activated sludge process, okay. Sometimes it can be and sometimes it cannot be, okay, because okay, the nitrification can be done in a combined system or in a separate system. Combined system means both the carbonaceous oxygen demand and nitrogenous oxygen demand will be taken care in a single system, that is the combined system, and separate system is the carbonaceous oxygen demand removal will be taking place in one system and the nitrification will be taking place in a separate time. So, in combined system what will happen? The population of heterotrophic microorganism will be very high, and we have seen that the microorganism will be forming flocks, and this nitrifiers population will be comparatively lower, and the nitrifiers usually try to stay inside the flock, in the inner portion of the flock, and heterotrophic microorganism which is utilizing the organic carbon present in the wastewater will be in the outside of the flock. So, what will happen? Whatever the oxygen present in the system, if the oxygen concentration is low, so what will happen? The diffusion rate will be low. So, the whatever oxygen is getting diffused to the flock, it will be consumed by the heterotrophic microorganism in the at first, okay, and if sufficient oxygen is left over, then only it will be penetrating to the core of the flock. If it penetrates to the core of the flock, then only it will be available for the nitrifiers. So, if you go for combined system, then the dissolved oxygen concentration required for efficient nitrification is very high. That means unless a residual or a dissolved oxygen concentration of 2 milligram per liter is not maintained in the system, nitrification cannot occur. Okay, that is in case of combined system. But when we talk about separate system, okay, the carbonaceous oxygen requirement is taken care in one tank and the nitrogenous oxygen demand is taken care in the another tank. So, at the second tank only nitrifiers will be present. So, whatever the little oxygen available, it will be sufficient for the nitrification. So, depending upon the system, okay, the oxygen requirement will be varying. We have seen that the ammonia or the organic nitrogen, whatever is present, okay, that will be getting converted to nitrate with the presence of nitrifiers. That means nitrosomonas and nitrobacter. Nitrosomonas convert ammonia to nitrite, that means NO2 minus, and nitrobacter converts NO2 minus to NO3 minus. But is it advisable to discharge a high nitrate containing wastewater or treated water to inland or the existing water bodies? It is not, because we know that nitrogen and phosphorus are the essential nutrients for plant growth as well as microbial growth. Okay. So, if the nutrients are present in excess, what will happen? There will be excess algal growth in the water bodies, or eutrophication of water bodies will be taking place. So, it is not advisable to discharge high nitrate containing wastewater or high nitrate containing treated water to water bodies. And moreover, we have seen that if high nitrate content is there in the drinking water, okay, if the concentration is more than 10 milligram per liter as nitrate nitrogen, the methanoglobinemia, okay, this is a disease which is affecting the infants. Okay, this we have discussed in detail when we were discussing about the water and wastewater characteristics. Okay, this also will be there. So, it is not advisable to discharge a high nitrate containing wastewater, and permitted level is 0.3 milligram per liter for inorganic nitrogen and 0.015 milligram per liter for soluble orthophosphate. So, this nutrient removal is very essential. So, how can we remove this nitrate whatever is present in the wastewater? Because the treated wastewater will be containing very high levels of nitrate. So, what are the methods we can adopt for the nitrate removal from the treated wastewater? Those methods are, one is ammonia stripping, okay, by aerating, okay, before nitrification itself we can remove the ammonia. So, once the ammonia is removed from the system, there will not be any nitrate, because the initial compound is not present. So, the oxidized form of that compound will not be generated. Next one is selective ion exchange. Okay, if you have nitrate present in your system, okay, you can use ion exchange resins, okay, which is having high affinity to nitrate or anions, then they can remove the nitrate present in the system. And another one is breakpoint chlorination. So, this we have seen when we were discussing about chlorination. If ammonia is present, monochloramine, dichloramine, trichloramine, etc. will be forming, and if you again add chlorine, then what will happen? This trichloramine will be breaking up to nitrogen gas and chloride. And the first step and most commonly practiced process, especially for wastewater, is biological denitrification. So, microorganisms themselves can be used for the removal of nitrate from the system. That process is known as nitrogen removal or denitrification. So, we were discussing about the nitrogen removal or nitrate removal from the system. So, this nitrate removal can take place in two different ways. One is assimilatory way and another one is dissimilatory cellular functions. Assimilatory function is, we have discussed that what is the nutrient requirement for any biological system. Okay, the essential nutrients include nitrogen and phosphorus, and we have seen that for each gram of cell we have to supply 0.122 grams of nitrogen and around 0.023 grams of phosphorus. So, naturally if so much of cell growth is there in the system, So, whatever the nitrate present in the system will be utilized as a nutrient. So, that is known as assimilatory. The amount of nitrogen whatever is utilized for the cell synthesis, that is coming under assimilatory category, and dissimilatory one is the one which is utilized for other than cell synthesis. Okay, it can be used for energy purpose or just removing from the system. So, that is what I have written here. Assimilatory functions, nitrate is reduced to ammonia which serves as nitrogen source for cell synthesis, and dissimilatory function, nitrate serves as the electron acceptor in energy metabolism, or dissimilatory function is the one, okay, which is utilized for the catabolism of the cell, and assimilatory one is the one which is utilized for the anabolism of the cell. Okay. So, if you see the total nitrate utilization in the system, around 70 to 75% removal is taking place because of the dissimilatory function, and only 20 to 25% is getting removed because of assimilatory function. Okay. So, if you see how the nitrate is getting removed from the system, okay, we can see these are the prevailing equations. Nitrate is present, ammonia is getting oxidized to nitrate by nitrifiers, and nitrate is already present there, and we have to supply some organic matter, because we know that the nitrification will take place after all the organic matter present in the system is getting removed. So, there will not be any leftover organic matter in the system, but this denitrifying bacteria, most of them are heterotrophs. So, definitely they need some organic matter for their cell synthesis. So, we have to supply organic matter. Most of the time in the field we supply the organic matter in the form of methanol. Okay, we can even give the domestic wastewater as such. The organic matter whatever is present in the domestic wastewater can be used as the food for this heterotrophic denitrifiers. So, what will happen? The nitrate is getting converted to nitrite, then carbon dioxide and water. Then again this nitrite will be reacting, or the nitrate will be utilized by the denitrifiers, and finally we will be getting 3NO2 plus carbon dioxide plus water plus 6OH. So, we have seen that in nitrification acid is produced, that means 4H plus was coming out, and in denitrification we can see that alkalinity is produced, 6OH ion is coming out, or in denitrification reactors the pH will be coming up, whereas in nitrification reactors if proper buffering capacity is not there, the pH will be going down. So, if the overall reaction is something like this, 6 nitrate plus 5 CH3OH gives you 5 carbon dioxide, 3 N2, 7 H2O plus alkalinity. And this denitrification, okay, we have discussed, okay, for any metabolic process, okay, the energy is derived from oxidation reduction reactions. For any oxidation reduction reaction, there should be an electron acceptor and an electron donor. So, here the electron donor is nothing but this methanol. Methanol is acting as the electron donor, and we want to reduce this NO3 to N2. So, this is getting reduced. Okay. So, when one compound is getting reduced, okay, it will be definitely accepting electrons. So, in denitrification the electron acceptor is nitrate. So, denitrification is coming under the anoxic process, or okay, we do not have to provide any aeration for denitrification. If aeration is provided, then what will happen? Other heterotrophic microorganism will be growing faster than these denitrifiers, and proper denitrification will not be taking place in the system. So, denitrification is an anaerobic respiration, that means in the absence of oxygen this denitrification will be taking place, or precisely we can call it as an anoxic process. So, inorganic compound containing oxygen will be acting as the electron acceptor. So, this is about denitrification. Till now we were discussing about the water and wastewater treatment, okay, which is mainly engineered by the people. Okay. We know what is happening in the nature, and we want to increase the rate at which the reactions can take place. So, we provide the required environmental conditions in the reactors or the closed chambers, so that the microorganism will be growing at a faster rate and they will be utilizing the waste in a faster rate, so that we can reduce the volume of the reactor and we can increase the rate or we can increase the treatment efficiency. So, that is what we were discussing about till now. Okay, we have seen activated sludge process, we have seen what is nitrification, what is denitrification. So, now we will discuss about some other suspended growth system where so much of engineering is not required. Okay, we are mostly doing the waste treatment, okay, we are allowing the waste to be treated by the natural forces, or whatever is happening in the nature, we allow them to take place in a proper manner and the waste treatment will be taking place. Okay. So, that is what is happening in ponds and lagoons. So, what is a wastewater pond? It is a large, shallow earthen basin in which wastewater is retained long enough for natural purification process to provide necessary degree of treatment. So, the important thing is here the retention time is long. Okay, we have to retain the wastewater for long time and the process is natural purification. So, we allow enough time for the wastewater so that natural purification will be taking place and we will be getting the necessary degree of treatment. And these ponds are known with different names. Okay. Sometimes people call them as oxidation pond, stabilization pond, sewage lagoon, polishing pond, maturation pond, etc. Okay. We will see one by one in detail. In ponds and lagoons, oxygen supply is mainly by photosynthesis, diffusion of air from the atmosphere. Okay. Natural diffusion of air will be taking place and the air will be entering by photosynthesis. And first we will see how can we classify the ponds, then we will be coming back to the mechanism in detail. Okay. So, what we have to keep in mind is ponds are the system, okay, where we detain the wastewater for such a long time that the natural purification will be taking place and we will be getting the necessary degree of treatment. So, we will see now what is an aerobic pond. Aerobic pond is a shallow pond, the depth is less than 1 meter where dissolved oxygen is maintained throughout the entire depth. That means, if you see the entire depth of the tank, okay, the depth will be varying from 0 to 1 meter, okay, the depth will be very less. So, if you see the dissolved oxygen concentration, okay, the entire tank or entire pond will be having some dissolved oxygen concentration, or at any time the dissolved oxygen concentration will not go to 0. So, that is the pond which is known as aerobic pond. In facultative pond, what happens? The ponds of 1 to 2.4 meter deep which have an anaerobic lower zone, a facultative middle zone and an aerobic upper zone maintained by photosynthesis and surface aeration. So, that is a facultative pond. Okay. So, it will be having 3 distinguished layers. The bottommost portion is anaerobic layer, because when the wastewater coming, okay, it will be having so much of suspended solids. So, definitely it is retained in a closed system. So, everything will be settling because the pond will be having a quiescent condition. So, everything will be settling down and the depth of the pond is so high, it varies from 1 to 2.5 meters. So, and we do not have any provision for mechanical aeration or artificial aeration. So, aeration will be taking place because of photosynthesis of the algae present in the system and the natural re-aeration. Okay. So, the oxygen entering in the system will be very less compared to artificial aeration. So, the dissolved oxygen concentration in the bottom of the tank will be 0. So, there the anaerobic condition will be prevailing and the organic loading or organic concentration is very high. So, that is why the anaerobic zone, and above the anaerobic zone you will be having the facultative zone. There the microorganism which can survive under aerobic condition and anaerobic condition will be there. There the dissolved oxygen concentration will be varying almost 0 to 0.5 milligram per liter or something like that, and in the top layer we will be having a complete aerobic zone. This aerobic zone is maintained by the photosynthesis of the algae and by the natural re-aeration process. So, there all the aerobic bacteria will be present. So, these bacteria are responsible for the organic matter removal in the top layer, and in the bottom layer anaerobic degradation will be taking place. Now coming to anaerobic pond, these are very deep ponds receiving high organic loading such that anaerobic conditions prevail throughout the entire pond depth. Okay. In anaerobic pond, the organic loading is so high that even the natural re-aeration cannot provide any dissolved oxygen content in the system, because the oxygen demand of the entire system will be so high. So, entire tank will be staying in anaerobic condition. Okay, this type of tanks are used for treating high organic content or high BOD or high COD wastewater. For example, if you have the distillery wastewater, okay, the BOD, the COD values varies from 50,000 to few lakhs. So, we can see that what is the oxygen requirement for such wastewater. So, if you allow them to stand in a tank or in a pond, okay, the oxygen requirement will be so high, even though it is exposed to the atmospheric conditions, the oxygen transfer will not be sufficient to provide any oxygen to the system. So, that is what an anaerobic pond is. Now, coming to maturation ponds, these are the ponds used for polishing effluents from other biological treatment units, okay, maturation ponds. And aerated lagoons are the ponds oxygenated with the action of surface or diffused aerators. So, maturation ponds, okay, they are coming under aerobic ponds most of the time, because it will be long, narrow or long wide ponds, but the depth of the pond will be very less. So, the major function of this pond is to polish the water or the effluent coming from other treatment units, because we have seen that if you go for conventional activated sludge process, the removal efficiency varies from 85 to 92%. So, remaining say 15 to or 7 to 15% organic matter whatever is present in the system will be coming out along with the effluent. Moreover, if you talk about the pathogens present in the system, okay, that also will be coming out with the effluent, because in any this conventional treatment system, either it is aerobic or anaerobic, it cannot take care of the pathogens completely, or the pathogen removal will not be taking place completely. So, if you want to discharge the effluent from such treatment plants to some existing rivers where people do bath and other recreational activities, so this is not meeting the effluent discharge standards in such conditions. So, how can we reduce the pathogenic or the microbial count in such systems? Okay. So, in such systems we go for the maturation ponds. So, these ponds will be retaining the effluent whatever is coming from the secondary treatment for long time, and it will be getting exposed to sunlight, and we all know that the sunlight will be containing lot of UV radiation. So, this UV radiation are responsible for the killing of the pathogens, and moreover we are giving such a long time, okay, in that this maturation ponds. So, whatever the untreated organic matter whatever is coming to this system, it gets such a long detention time, and definitely the microorganism will be growing in the system. So, that microorganism will be consuming the organic matter whatever is left over in the effluent, and finally we will be getting clarified effluent. That is why we are calling them as maturation ponds. And aerated lagoons are the ones which are the ponds where we give artificial aeration, whatever the natural aeration what is happening because of the oxygen deficit exists in the system, that may not be sufficient for the proper treatment of the system. So, in such cases we have to give externally the aeration. So, any pond where we provide external aeration, that is known as aerated lagoons. Aerated lagoons also can be classified into two categories: aerobic lagoons and facultative lagoons. In aerobic lagoons what will happen? Complete system is in aerobic condition, and entire suspended solids whatever is present in the system will be in suspension. That means the aeration will be so rigorous that all the suspended particle whatever is there, okay, whatever is already settled, everything will be coming into suspension, and definitely the treatment will be more efficient. Now, we will discuss about the facultative aerated lagoons. In facultative aerated lagoon also we are providing aeration by external means. That means we will be providing aerators, but in this system what happens is the aeration is not so vigorous as that of aerated lagoon or aerobic lagoons. So, the suspended particles, a portion of that one will be remaining in the bottom, or you will be having a facultative zone at the bottom of the tank, and the top portion will be completely aerobic, that is the facultative lagoon. So, now we will see what is the difference between a pond and a lagoon. Pond, there is no artificial aeration, but any lagoon means there is artificial aeration, and we have seen that what are the different types of ponds. One is aerobic ponds, another one is facultative ponds, and third one is anaerobic ponds, and fourth one is maturation ponds. And aerobic ponds, what is happening? Entire depth of the pond is in aerobic condition. The depth will be less and complete zone will be remaining in aerobic condition. In facultative pond, the top layer will be in aerobic condition, but the bottom layer will be in facultative condition. That means sometimes some dissolved oxygen will be there, but sometimes there will not be any dissolved oxygen present. Or the facultative zone, the microorganisms are such that they can survive in aerobic condition as well as anaerobic condition. While coming to anaerobic ponds, okay, entire depth of the pond will be in anaerobic condition. This type of ponds are used to treat high strength wastewater. That means the BOD of the waste will be so high that whatever is the means the oxygen is getting into the system, that will not be sufficient to maintain any dissolved oxygen in the system. And maturation ponds are the one which is used to increase the quality of the treated effluent, whatever is coming from other secondary treatment. Okay, that is the purpose of maturation pond. Mostly it is used to achieve the bacteriological quality for the discharge. Now we will see what are the things we have discussed today in detail. So we were discussing about aerators, and we have seen what are the major objectives of providing aerator. Okay, one is to provide sufficient oxygen to the system, and second one is to provide the necessary mixing, because mixing is essential for the proper functioning of the system if it is meant to work under completely mixed condition. And even in plug flow reactors, okay, though there is no longitudinal mixing, transverse mixing is allowed. And we have seen that both diffused aerators and surface aerators can be used. Diffused aerators itself, coarse aerators and fine aerators are there, and whenever we want to design the aerators, okay, the manufacturer will be giving a rating of the aerator based upon the standard condition. The standard conditions are 0 milligrams per liter of oxygen, and the pressure is 760 millimeters of mercury, and the temperature is 20 degrees centigrade, and the water used is tap water. But in actual field condition, the systems are entirely different. So naturally the oxygen transfer capacity of that particular aerator will be varying. So rating is just to get a basic idea of that aerator. So based upon that aerator rating, okay, we have to find out what is the field condition according to the prevailing condition of the wastewater or prevailing condition existing in the treatment unit. So by using proper formula, which include the correction for temperature, the correction for wastewater characteristics, and whatever is the oxygen deficit present in the system, we can find out what is the field capacity of the aerator. Once we know the field capacity, we can easily make out how many aerators or how many horsepower we have to supply to the system, so that the system will be getting enough oxygen. And we have also discussed about the oxygen requirement for nitrogenous compounds present in the system, because we have seen that in activated sludge process and all, we give more importance for the carbonaceous oxygen demand removal. Okay. But once the organic matter is removed, the nitrogen whatever is present in the organic nitrogen form or ammonia nitrogen form, it has to be oxidized. This oxidation is done by a group of bacteria known as nitrifiers. Nitrifiers consists of Nitrobacter and Nitrosomonas. Okay, one converts ammonia to nitrite and other converts nitrite to nitrate. Those are autotrophic microorganisms. Okay, once the entire ammonia is converted to nitrate, we are not supposed to discharge them like that, because excess nitrate can cause many problems. So if you want to remove nitrate, we can go for various methods like ammonia stripping, ion exchange or biological methods. Biological means is denitrification. Denitrifiers are heterotrophic bacteria. They utilize nitrate as the terminal electron acceptor. So, nitrate will be getting oxidized, getting reduced to nitrogen, and since they are heterotrophs and already whatever the organic matter present in the system is removed, we have to supply carbon source externally whenever we go for separate denitrification system.